This video will cover 4 of the following in regards to exponents: understanding exponents, addition and subtraction using like terms, identifying exponent laws, and applying our knowledge. Number 1. Exponents identify the number of times to multiply the base by itself. In our example, 3 to the power of 4, 3 is the base while 4 is the exponent. Therefore, we multiply 3 by itself 4 times. A common mistake when working with exponents is assuming that you multiply the base by the exponent. This is not correct. For example, 3 times 4 is 12, while 3 to the power of 4 is 81. Negative 12x squared has the following 5 key components: 12, the coefficient, x, the variable, 2, the exponent, a negative sign, and an invisible denominator of 1. Number 2. Combining like terms can be done in 2 simple steps. Step 1. Identify which terms are the same. The coefficients may be different, but the variable and exponent must be the same. Think of each variable with its corresponding exponent to be one type of fruit. Now that we have classified each term as its own fruit, we separate them into baskets and count them by combining the coefficients. Keep the rest of the term the same. Let's solve this question using the previous scenario. If we have 8 bananas and 9 apples, then we take away 12 bananas. We know that the apples are already in their own basket, but the 8y and the negative 12y can be combined to make a negative 4y. Therefore, our answer is 9x plus negative 4y. Number 3. There are numerous exponent laws to be aware of in algebra. Rules of 1. Any number raised to the power of 1 will equal itself. This is because 18 does not have a second 18 to multiply itself by, and so it remains as is. The second one is 1 raised to the power of any number will equal to 1. This is because 1 times 1 times 1, 18 times, is still equal to 1. Zero exponent rule. Anything raised to the power of 0 is equal to 1. Take a look at the screen. Every time you subtract 1 from the exponent, your answer ends up being the previous answer divided by 2, or the base. By the time we get to 2 to the power of 0, the previous answer is 2. You divide it by 2, which equals 1. 0 to the power of 0. This rule states that 0 to the power of 0 is equal to 1. The graph shows that as we decrease our powers into decimals, the solutions also decrease. However, at 0.3 to the power of 0.3, the solutions start gradually increasing. By the time we get to 0 to the power of 0, the answer is 1. Negative exponents. When coming across a negative exponent, we simply perform the opposite operation in order to change the sign into a positive. Since exponents are a form of multiplication, we divide. 5 to the power of negative 2 becomes 1 over 5 squared. In other words, we found the reciprocal of the base. Product rule. When multiplying 2 exponents with the same base, add the powers together. Why it works. Our example is x squared times x cubed. Let's rewrite the question in its expanded form. X times x times x times x times x. As you can see, there are 5 x's total, giving us x to the power of 5. Quotient rule. When dividing 2 exponents with the same base, keep the base and subtract the exponents. Why it works. Let's write x cubed over x squared in its expanded form. Now cancel out. All we are left with is 1x. Power of a power rule. When raising an exponent to another power, multiply both exponents together. Why it works. Our example is x squared to the power of 3. When we expand, it is x squared plus x squared plus x squared, meaning there are 6 x's total.